Hello everyone. Today, as part of the ore training video program, we're going to explain you how to easily build and calculate the NPV of an equity option with implied volatility surface. Generally speaking, as an advice, it is easier to use the input files from the examples provided in a repository and then modify them rather than completely starting from scratch. We are going to start with the file usually named ore.xml, which we also tend to refer to as the master XML because it contains information about the rest of the input files and some general settings. There are three main nodes in this file. In the first one, the setup node, we have the valuation date, which is set here to the 24th of June 2021. We have the name of the input and the output folders. We have the name or the path actually to we have seven here input files. We also have information about the name of the log file, its verbosity, and if we want to force the fixing to be implied, which is not needed here. In the market node for now, we just keep everything to default. It will be explained in a different video later. And in the analytics node, we only want to calculate the NPV. So here we just set the NPV active to yes, and we want the base currency to be in euro. The next file we're going to look at is the trade.xml file, which is where we're going to set up a portfolio of one trade, a European call option on the Euro Stoxx 50 index with an implied volatility surface. So the first thing that we are going to define is the unique ID of the trade. Then we have the node containing the type of the trade, which is here the equity option. Then we have the node containing the equity option detail, named equity option data, in which we have the following nodes. We have the name of the underlying, which is here given as a Rogers instrument code, RIC, referencing the Euro Stoxx 50. We have the currency of the underlying, which is set to euro, the strike value set to 4,000 euros, the quantity, which is the result of the number of contracts multiplied by the size of each contract. So here it's 1 by 1. Then we have all the data relevant to the optionality of the trade. If it's long or short, if it's a call or a put, the style of the optionality, which is European here, but we can also have American or Bermudan. We have the settlement type, usually cash for equity options, but there's also physical, mainly used for commodities. And then we have the exercise date schedule, which is just one date here, given it's European. Just to give a more visual information about this trade, this is the type of payoff we're going to have. You can see that it's a long call with a strike set to 4,000 euros. The difference here is the price of the option, which we'll see later is 260 euros. And you can see that the current underlying price is set to 4,122 euros, which means the trade is for now in the money. Then we need to define which type of model is going to be used for our European equity call. Here in the pricing engine file, we have to define for the product type equity option, the type of model that we want, and here it's a Black-Scholes Merton with an analytics European engine. You can see here the famous formula for Black-Scholes with the different inputs that are needed. Then we need to configure all the market inputs, and I'll walk you through the logic. So what inputs do you actually need? We need obviously the equity spot. We need the equity forward. Now this one's a bit particular because in ORE we need to split by its components. And the components are the equity spot, the interest rate forecasting curve, the equity dividends. The way we're going to do it here is just by providing a set of option prices, because this can be also used for the implied volatility. We provide also the euro EONIA, which will be which will be used as the forecasting curve. And given that we already have the equity spot, we can then imply the equity forward value, and from there we can imply the dividends. Now we could have also provided directly the equity forwards instead of the stock option prices, but in any case we will need to provide the forecasting curve. Then we have the equity implied volatilities. Here it's volatility surface. That means that by providing the option prices that we already defined before, we can imply the value of the volatility surface. And finally, we have the discounting curve, which you'll later see we defined as the euro uni as well. Now let me show you how this is configured in the rest of the input files. Curveconfig and today's market will provide the settings, and market data and fixings will hold all the actual market data values. Convention, well, it will obviously call all the convention, and it's a bit more of a fixed file. In today's market, we have set everything to default, and that is a reference to what we have set up here to default as well. So first of all, we'll look at the equity curve configuration. In today's market, for RIG stocks 50, we have defined a sort of path to an equity euro RIG stock 50. This is a reference to equity curve, currency euro, and the curve ID RIG stock 50. The curve description is mainly used for the user when looking at this file. It's not actually used in any of the pricing. The forecasting curve, as we mentioned earlier, we have used the euro union. The next few lines define the type of input which are going to be used to build the equity curve. Here you can see that we've chosen the option premium type, but there's actually a few other types, as you can see in the user guide. You can also use dividend yield, forward price, option premium, no dividends, and forward dividend price. When we define option premium, we need to define what type of option the inputs are, and here we're using European style option premium. Here, this is a reference to the spot of the equity, which you can find here in the market data. And then here, with its wildcard at the end, this means that we are making reference to all other quotes starting by this path. And you can see in the market data, there's actually more than 3,000 of them defining the option premium surface. Then you have the decounter, and you have a few settings of the interpolation and extrapolation. Then we're going to talk about the equity volatilities, which are defined in a very similar way as the equity curve. In today's market, you have the name RIG stock 50 with its past equity volatility, which is here, euro for currency euro, and RIG stock 50 for the curve ID. Curve description, it's a log normal option implied vol. Decounter is A365, and then with this node, the volatility config, you define the inputs which are going to be used to imply the volatility surface. This is actually the same input as for the equity curve. We use option premium, European. Here we don't define any strikes in particular, just a wildcard, same for expiries. And then after you have a few optionality on the time interpolation, the struck interpolation, and different other type of extrapolation. We don't need any extra market data because this already has been defined in the market data file while we were building the equity curve. The next market data configuration we want to look at is the interest rate curves. So we've seen before we have a forecasting curve the euro Ionia, which is being called in the equity curve node in the curve config. And its reference in the today's market file in the index forwarding curve node, as you can see here. For it's calling the past yield for yield curve, currency euro for currency, and curve ID euro Ionia. And we also have a discounting curve, which is actually not called anywhere else except in today's market file. Here with the discounting curve node, where you can see that this is defining the euro discounting curve, and it has exactly the same path as for the index forwarding curve. So both of them are referencing exactly the same curve, the euro Ionia. One important thing to remember about the euro Ionia is that since the 1st of October 2019, it has become a spread-based curve. So now it's actually the euro ester plus 8.5 bips. And this is something you can see in the way it is defined in the curve config file. We have a reference curve, the euro ester, and we have a type of curve which is actually a zero spread. And we will call the spread from the market data this way. The reason why we actually have two quotes here is just to avoid having issues with interpolation and extrapolation. By just defining two same values, you are sure that even if it's interpolated or extrapolated on the tenors, it will be exactly the same way. And you can see it here. This is your 8.5 bips. It also means that we need to define another yield curve for the euro ester, and this is done in the curve config file here, the euro ester, and in the today's market file, you can see we have a second index forwarding curve with a path very similar to the euro Ionia. Now the euro ester is actually a curve which is built using deposit rates and also OIS rates. So it will be bootstrapped with these two type of quotes. You'll see that we have quote rate euro ester, which is defined in here, and you will have a series of quotes for the OIS, which will going to be defined in market data here. Now there's two last files that we haven't looked at too much yet. The fixing files, there's actually no fixing calls for this type of trade, so we have to define the file to create the file and to call it, but there's actually nothing in the file. And we have the convention file. You can see that we are calling a few conventions in the yield curve in curve config. We have the first convention for euro 0 tenor based, and it's going to be defined in here. We have a second for the deposit quotes for the euro ester, which is defined here, and we have a third one for the euro ester iOS, which is defined here. And that's pretty much what you need to build this European option. Now that we have defined all the input files, let's look at how we're going to price it. So the first thing you want to do is just go to where you define all your input files. So copy the path, open a command line, do your cd in that folder, then find where your ore.x has been saved. For me, it's going to be in ore app bin times 64 here. I have a release. Then you copy the path to this cd. Then you want to call the ore.x, and then you just give the name of your main XML, which is going to be ore.xml here, and you just have to press. Normally, if everything works, you should have ore done at the end, and you can look at the result of your calculation in the output folder. Opening the NPV file, you can see that we have the price of your options, 236. That's something that we looked at first in the graph here. And you have further statistics about how the calculation went with pricing stats here, how long it takes, and the number of pricing that you've done. And this is it. Thank you for listening, and see you in the next video.